We are now going to look at how to integrate powers of tangent and then secant, and then a combination of tangent and secant. Now, if you recall, there is an identity which relates the secant square and tangent square, and this can be obtained actually from the original or the basic fundamental identity sine square x is plus cosine square x is equal to 1. If you divide the whole equation or whole identity by cosine square x, then you end up getting this the other Pythagorean identity. There is a third Pythagorean identity which relates the cotangent square and the secant square, and this again can be obtained from the basic fundamental identity by dividing the whole identity by sine square x. Well, we will not be using the last one, or we won't need that one unless, once in a while you might have to see cotangent or cosecant inside the integral, but mainly we are going to restrict ourselves to sine, cosine, tangent, and secant. So let's look at what happens if we have powers of tangent. How do we integrate powers of tangent? So the first we start with the basic one, just tangent x. Now again, this is something that we have seen before, but I'm putting it again or doing it again just to make sure that you know. Also just with for the continuity of the these examples that we are doing. So the first thing we are looking at, there is a 1 power on tangent. So then the way this is done is we write it like sine of x over cosine of x dx, and this is, by the way, is unique. Not all problems will be done this way, so you have to remember this kind of trick. So maybe let me write here trick. So this is like a special case. So you can now say let u equals cosine of x, then du is negative sine of x dx, and now we go back and replace. So we have sine of x over u times du over minus sine x. So what did I do? From here you can find dx, which will be du over minus sine x. So replace it here. Now sine x and sine x get cancelled, and we have negative integral 1 over u du. Now the integral of 1 over u, if you recall, is ln of absolute value of u. So I get negative ln of absolute value of u plus c, and u is cosine, so negative ln of absolute value of cosine of x. Now note here we have to put the absolute value, because remember cosine can take on negative or positive values, and ln of negative value does not exist, so we must have a absolute value plus c. So basically that is the integral of tangent x, but often we go one more step and write it as ln of absolute value of secant of x plus c. So this is the answer for finding the, and I hope you guys can see where did I get this secant from. So remember, negative ln of cosine of x can be written as ln of cosine of x whole raised to the power negative 1, or ln of 1 over cosine of x, which is equal to ln of secant of x. Now note here, this negative power is not the inverse, so you have to remember these things, that cosine negative 1x is not the same as, so these are like basic notation thing that you learn when we are introduced with these functions. So this is not the same as cosine of x to the negative 1. Yes, if we have other powers. So if we have cosine square x, yes, that is cosine of x whole square, but the inverse, when is not becomes the, it does not become the power. So these are very, very important things that you have to remember. Okay, looking at the next one, actually this is pretty easy. So we will use that identity up there to convert the tangent square into secant square. So we can write tangent square equals secant square minus 1. So this can be transformed into secant squared x minus 1 dx. And now you integrate, well, integral of secant square x is tangent x, and then minus 1 dx, so get x plus c. So there it is. We got the antiderivative of tangent square x. What if we have tangent cube x? Well, then we have to again manipulate and try to keep some things and change some things. That's what we do. So we will now keep, so in note here, this is an odd power on tangent. So we will keep one tangent x and then the other one will be tangent square x. So we can write tangent cube x as, split it like this using the exponent rules. So the tangent x I will keep as it is, and the tangent square x we will convert into secant square x by using our identity. So we get tangent of x times secant square x minus 1 dx. Expand, so we end up getting tangent of x secant square x dx minus integral of tangent of x dx. So now the last integral here, we already know from up there what the integral of the tangent x will be. Now how do we do that? This other one, well, we are going to do a substitution. So we say let u equals, so what will be our substitution? Remember, the derivative of the tangent is equal to secant square. So we will say let u equals tangent x, so that du is secant square x dx. And now if you come here, well, tangent x is u and this whole thing is just du. And then integral of tangent x, you can already write, is negative ln of secant x. And then this becomes, so the first term now becomes u square over 2, the second minus ln of secant x, and then plus c. Go back, substitute the u square, so we get 1 over 2 tangent squared x minus ln of secant x plus c. So when you will have an odd power on tangent, this is what you will do. You will first keep the, kind of take out 2 of the tangent or tangent square. You will separate tangent square and then keep the rest of the power on the other tangent, and then convert the tangent square into secant square minus 1, and then distribute and use substitution and so on. So we will see when I will do tangent of 5x and see what happens. Okay, so the next one is tangent to the 4x dx. Again, this is an even power. So whenever we have even power, the same trick that we did before. So we'll keep the we will separate the tangent square and then keep the other power on the tangent as it is. So we have tangent 4 can be written as tangent square x times tangent square x dx, and we will now keep one of the tangent square as it is, and the other one we will use the identity. Okay, we now distribute, so we get tangent square x secant square x dx minus integral of tangent square x dx. So the second one, this we already know from up there how to do it. We will again convert it into secant square minus 1. So note here we are not changing this to secant square minus 1 here, because if we do that, everything will be converted into powers of secant, and then we have not yet even learned how to do the powers of secant. So we have to convert it into secant square minus 1 in like steps. So for the first one, we will use a u substitution. So let u equals tangent of x, then du will be equal to secant square x dx, so that this integral becomes u squared du, and this one we can write as secant square x minus 1 dx. So now this first integral is u cube over 3 minus tangent of x plus c. Go back, substitute u, so we get tangent cube x minus tangent x plus c. Okay, so what if we have tangent to the 5x? So we are again going to do the same thing. We will keep the tangent cube x here and then separate the tangent square x dx, so that we can change this, the tangent square x into secant square x minus 1 and then distribute. So we get tangent cube x secant square x dx minus integral of tangent cube x dx. So what do we do now? Well, we just learned how to do deal with the tangent cube x. So again in this one we are going to separate the tangent square and convert it into secant square minus 1. So let me do that. So first one stays as it is, minus, and this will become, well, note here, tangent, we will have tangent x and then we will have secant square x minus 1. So this will become tangent x times secant square x dx minus integral of tangent x dx. So now we can integrate. Actually, we can now do a u substitution. So we say let u equals tangent x, then du is secant square x dx, and now we go back and substitute. So this gives me u cube du minus u du, and then minus. Now this one we will do it the way we learned. So this will be secant of x plus c. So now just simple, 1 over 4 u to the 4 minus 1 over 2 u to the 2 minus ln of secant x plus c. Going back, substituting for u. So we have 1 over 4 tangent 4x minus 1 over 2 tangent 2x minus ln of secant x plus c. So let's now look at what is happening here. Can we see a pattern here? So note that when n is odd, so like the example number 4, so you are getting the odd powers of tangent, and then you are getting a plus x in the end plus c. And when you have even powers of tangent, or when we have even, so I will write it like this. So if we have tangent nx dx and n is odd, so it will be 1 over n tangent of nx minus 1 over n minus 2 tangent of 1 over n plus 1. So we when n is odd, so we are looking at example 5 here, not at example 4. So that when n is odd, we are getting 1 okay, I think I will write it over again. It's taking me long to cross this one, so we'll just delete this one, so I'm cross it, and then I'm going to, so when n is odd, we will get 1 over n minus 1 tangent of n minus 1 x minus 1 over n minus 3. So if you notice what is happening, we have a difference of 2. So n minus 1 minus 2, which will be n minus 3, tangent of n minus 3, and then minus dot dot dot, so minus until we get to 1 over 4 tangent 4x minus 1 half tangent square x, and the last term will be ln of secant x plus c. And when n is even, so you can see a similar kind of a result for n is even. So when n is even, so integral of tangent nx dx, what does it become? So this is, so when n was even, so we add n is equal to n raised to the power 4, but you see the term, that first term is 1 over 3, so which means again we get 1 over n minus 1 minus 1 over n minus 3 minus dot 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 minus 1 over 3 tangent 3x minus 1 over minus 1 tangent x, and then we are going to get plus x plus c. So you guys can try. So for example, you guys can try integral of so tangent to the 6x dx, and try to see if the result that we get is the same that we get from using these formulas that I wrote here. So formula 1 and then formula 2, you can call it. And also try tangent of 7x dx. Okay, in the next video we will look at powers of secant.